Okay, so what is artificial intelligence? If we can look at it, it's essentially a technology that tries to mimic human intelligence, right? So what sets you apart between a computer and a human being? What's the difference between you and a computer? Essentially, is you're able to think about things, you're able to imagine things, you're able to sit in a class and learn, you're able to join this Zoom and learn something new. You're able to also improve how you think about things, how you see the world, how you perceive it. But a computer is essentially just good at enabling you to solve problems. You want to see the other person on the other side of the screen. Well, I have a computer for it. I have a software for it, Zoom. I want to chat with someone, you know, I want to write something to them, something sweet. I want to write something hateful, whatever. I want to have a human expression to someone else. I write a text. So, or I'll give them a call, right? So we have the phone for it, we have a message for it, we have a software for it, WhatsApp, it's there, right? So essentially in this technology, we now try to look at the computers and say, hey, how about we come up with a computer or a software or a technology that essentially can just do some tasks that we do but more intelligent. No, more intelligent than us. So that's when this idea of artificial intelligence comes about. We're trying to make computers to think about information and data that they have and process it. We're trying to make the computer learn from the difference between a few things, one or two things, then adapt. Then we're also trying to make computers improve from their learning. We're trying to make computers to understand and see, okay, we moved from 80%, now we want to go to 90%, right? So essentially, if we were to put it in a classroom, the same way we go to class and we teach kids, we introduce them to A, B, C, and D, we show them different images of an apple. We show them images of people, human beings, and animals. That's a, that's similar to the experience we're trying to give a machine here, a computer here, right? So we take them through class and we teach them as a kid. We train them on ABCD through data. So we show them this A means apple, this B means boy, right? Then we give them a test, the same way we do to a kid in class. So we introduce the same thing. Let's say we put an A and we say, what is this? Then it has to fill by itself to identify what does A represent? What does B represent? Then we also have to check and see if the computer is able to pass this test or fail this test. So this is, if we break it down, this essentially is not as magical as we put it out. Certainly are the results. The results are magical to us because the technology keeps on surprising with how the computer is able to learn. But certainly it's not that magical. We're essentially just taking a computer to class, right? So what is not AI? Because we have all these ideas of what AI is and what AI is not, right? So what do we mistake AI to be? The first one that you probably heard is that, oh, robots will do everything, or, AI will be able to do everything. I'll sleep, it will wake me up. If I'm about to get hit by a car, it will probably tell me, it will tell me the levels of laziness that is in me when I try to wake up in the morning. But AI will not do everything for you. You still need human beings. So if you are dreaming of having a robot and zero human interaction at some point in your life, and you wouldn't want to interact with human beings and only having artificial intelligence systems around you, Well, I'm sorry to break it down to you. That's probably not going to happen. You still need humans in a lot of processes. I mean, a good question for you would be currently, would you trust, uh, if you are going for surgery, would you trust an artificially intelligent doctor, or would you trust a medical doctor who has done the same thing for 10 to 15 years, right? There's something that they have that the AI probably does not, and there's something that the AI has that the doctor does not. So that means that both of them will probably need each other. They will complement each other, right? So you're not taking human beings out of the equation. So that means if you're not taking human beings out of the equation, you will need other people. So AI will not do everything for you. So that is not AI. That is probably your dreams. Then the second thing is, you know, AI is going to be as, a generalist as human beings are. So essentially, we're thinking of AI is going to be like us human beings, to be able to do all that to a certain human level. Well, it's desirable to have made a computer that is, at the same level of intelligence. But the fact that we are the ones who are making that system already makes us more intelligent, right? You're still the creator of that type of AI. So it is essentially very hard to create an AI that is close to a human being. It is very hard. And remember when I gave the example yesterday where I said when we're having a conversation in a bar or when we're just lounging together or even at the office and I say, hey, the cold in Canairo is brutal. Then there's another person replies like, yeah, sure, Nairobi is pretty cold, right? Those are two things. Canairo and Nairobi mean the same thing because for us human beings, we probably get it's a lingo, it's a language between us. We've created that lingo among us, right? A computer might know Nairobi, an AI might know Nairobi, but it may not know Canairo. It really might not, right? And how many of those examples do we have? Those nuances do we have? And that is only in speech. um, Sometimes in action, like if I do something that a sarcastic act to another human being, a machine might struggle getting that context. So AI is not probably not going to be as generalist as we think. It might not open doors, cook, do everything, or become a wife or become a husband, right? It might not. It might be good at some things and be very good at some things, probably do one thing very good more than human beings, but it might not get to a level where it is very good at every general thing. The third one is, and this one is probably spoken out of hubris by people who are already in fields of STEM, science, technology, and medical and science fields, where someone will say, AI is just repackaged statistics. It's just statistics that, is just statistics with lots of data and lots of power, computing power. But AI is exactly not that. It surpasses that to some degree. We're trying to make a technology that mimics human activities and human intelligence, right? So it will not be the usual software that we make because um, we're trying to make a computer that is able to sometimes learn sentiment, whether a statement is good or bad. We're trying to make a computer that is able to process billions of thoughts and be able to give you a reply. A good example is when you go to Google Translate and type in French or English, then translate it, right? That's at the back of whatever is happening behind. it's way more than our usual statistics that we do. We'll just predict this, or this is what is going to happen. It is way more than that, right? So we cannot just place it as, it's just a repackaged statistics. So let's just think of where this technology is coming from, because it's really popular right now, and some of us think it's something that popped out in 2010 or in 2018, but this has been a pretty old technology. It has been with us since 1956. So the guys who started it, the first person who probably is named the father of AI. The reason why he's named the father of AI is because he's the one who coined the term of artificial intelligence. He's the one who, in 1956, they came together as a group of computer scientists, and they drummed up ideas on how can we make how can we come up with computers that are close to human intelligence, or they're at the same level of human intelligence. How can we coin an artificial intelligence of our own kind, of our own human being kind? Like, how can we make a computer just reason and perceive the same way and solve problems the same way a human being would? So John McCarthy was the first individual that really pushed for this. He came up with a programming language called Lisp, and his idea of AI was essentially around robots being able to make, lifelike human being structural robots that will try to mimic human intelligence, like act like us, speak like us. And that's why, for the most part, most images that you see of AI or a representation, even in posters, is probably a robot somewhere. And I won't be surprised if a majority of us would think that AI is only robots, right? So the second individual that is also someone who's very significant in this technology is Alan Turing. So his work has been hidden because he used to work a bit for the military during that time. So he came up with something that is very essential in AI. He came up with what we call a Turing test, which is a test given to computers to see just how good they are, if they've gotten at a human level. So since 1950s up to 2021, we still do not have any AI that has passed the Turing test. So that's why when I see people you know, getting all excited or having lots of fears and saying, "Oh no, AI is probably going to take over." Well, guess what? Since 1956, AI has not been able to pass the Turing test. And the Turing test is a very simple test. Is when you when you get a computer to do an activity and you get a human being to do an activity, and you introduce human beings who will come and assess to know if these two tasks which task has been done by a computer and which one by a human being. If a human being can still easily be able to pick out this is work done by a computer as opposed to a human being, it has failed the Turing test, right? Such a very simple test that, as much as we have built very complex artificial intelligence systems, it still fails a very simple human test, right? So right about that, after Alan Turing created this technology has been very silent. It has probably mostly been hidden in labs. It has mostly been kept in universities as research. And right about until a professor called Geoffrey Hinton picked it up. And what he was able to do is he brought up a new idea of, if we want to really create an artificially intelligent system, we ought to look at what represents intelligence in human beings. And that is essentially the brain. Like that, the brain is what represents intelligence for human beings. It allows us to reason, allows us to perceive, allows us to learn and to imagine and to think and to process, right? And to solve problems out of all that. So he tried to study the brain and how we make decisions. And our brain essentially has neurons, which allow us to, you know, probably differentiate between one or two or three things. That's one. And it does way much more. I mean, there's so many things. You wake up in the morning and you want to know if you're going to wear a green or blue suit, to a level in which you have to solve a very huge problem when you're at work or when you're studying for an exam or you're sitting for an exam, right? So he tried to come up with a way in which computers will mimic human brains. And he came up with what we call deep learning, which we're going to look at later on. And that has been widely adopted because it took so many details the same way you would analyze and study something and come up with a conclusion on whatever you're looking out for. So he also took close to 40 years until we recognized his work, right? So his work has made AI popular right now for the most part, because out of his breakthroughs, we've been able to try to take AI a bit more seriously. So that's why we call him the godfather of AI. So why is AI booming right now? Why are we hearing all this talk? You remember, if you're old enough and you're in the chat, you remember the times when internet was coming out, right? So, it was a whole jazz that we had, like, what's going on? What is the internet? Same way, it's like, what is AI and why are we so interested in it? And why are companies like Google and all these big companies trying to run and do something about it? So, well, and why, let's also ask another question, is why since 1956 to date are we starting to see the benefits of this technology, right? So there are three reasons why AI as the technology is booming right now. And the first one is increasing data. Just imagine for a second, how much data do you produce per person? You have your phone, you're sending out a text, that's data you're generating. You're taking a screenshot, that's data. You're going to Instagram, that's data. You are joining this Zoom, that's data. You are looking at, you're probably watching TV, that's data, right? All that is you producing data. And that's just you as an individual. So you use your phone, you're generating data. You use your laptop, you're generating data. So those are just two devices that you have on a personal level. Now imagine how much data are we producing from a car? How much data are we producing from um, TV? How much data are we producing from all this together, all of our data together combined to when you go to the office and you have a computer there, you have a desktop there sitting there. You have an IT department that is busy telling you, hey, upload things, please upload, use this drive, upload things here. All that, all that is this data being generated. So you probably produce, the world is producing 2.5 billion. That's data per day. Yeah? And that's why we usually say the world has generated so much data than we ever existed in a period of 2 to 3 years. Anytime between now and the last 3 years, you produce so much data than the previous years. That's how much you're producing data, right? Then the second thing is we have decrease in cost, computation cost. Now we have phones. Initially, people having and owning a phone used to be a luxury. From Nokia 3310 to Motorola, from all those times up to now, even owning a laptop is will show you that the cost has gone down. We came from having one computer in the house to even our kids in high school and primary owning devices. So the cost of being able to own something that is collecting data, which is essentially your phone, your laptop, the more you interact, the more you generate data, has also reduced. So that cost has reduced. Then the third one is our ability for us to keep all this information that we are producing in sophisticated places. Remember when you back up your data and it goes to something called the cloud, right? That essentially is a data storage. It's essentially you're storing your information in someone else's computer. So if you think you're pushing it to the cloud, I'm sorry, you're just pushing it to someone else's computer. So all this jazz that we have, like AI is booming, is essentially just because of these three things. And why is it that in increasing data and the cost of us buying phones and computers has gone down, and in sudden increase in data storage, we have a lot of AI coming up. The reason why we do that is because AI, in trying to learn and in trying to mimic human beings, we're taking it to class, and we're taking it to class with what? With data. It has to learn from data in order for it to mimic or to come up with any sort of intelligence. So let us look at types of AI, right? Let us look at types of AI, because when we say AI, it's essentially a very broad topic. There's so much we have to dig into. So there are three types of AI. The first one is narrow AI, the one that is mostly popular, and it is where we are. The second one is general AI, and the third one is super strong. So let's dive into them. So narrow AI is essentially AI that is made to perform a single task better, right? So a good example would be, you see, if you use, how I'm pretty sure all of us here are using, probably own a smartphone one way or another. Everybody's owning a smartphone, right? So in that sense, if your smartphone is able to tell you the weather tomorrow, right? It's only good at predicting the weather. It's not good at anything else. Ask it anything else, it doesn't know. It doesn't really know, right? Same case to advertisements. When we go to Instagram and we spend a little more time looking at a certain bag or a certain image, well, guess what? We get more of the same images or the same content all together. Why? There is an AI existing made by Facebook that is pretty good at showing you things that you like, the interest that you like. Its only job is to know your interest, and that's about it. And that's why so many of the SMEs um, are using Facebook as a way of advertisement. They know that once they're able to upload this and sign up on Facebook with with a business account, they're able to advertise on Instagram, they're able to advertise on the same Facebook, right? So AI, narrow AI is essentially just an AI that is made to perform and is very good at performing a single task better. So if it's recognizing images, very good at doing that. Can't do anything else other than that. If it's recognizing voice, it is very good at that. Nothing else, right? So it only does one task well, and it's also mostly predefined. And we're going to speak about this a little more. So it's because it is very narrow and very specific with this task, we tend to give it data that is specific to its task. If we want something to recognize, if this is the true honor of the phone when we use image recognition to, open our smartphones as a form of security, we want to know if it's you or someone else, right? So we only show, we've made it really good at knowing you because we've showed it a couple of images of you, right? So that is narrow AI. And this is probably the most useful AI and the only one that exists. So let's move to the general AI. General AI is like step two, yeah? AI 2.0, where we've gotten the technology at a human intelligence level, right? The machine, the computer is able to think like a human being, act like a human being, and apply knowledge the same level as a human being, right? So we've made it to a level where it's essentially another artificial human being, right? So now that we think of this, it's actually not feasible yet, right? Some people are trying this, but the limitation of this is like humans are still struggling to understand our own intelligence. We don't know how much our brains can produce. We've made skyscrapers, we've made cars, we've made complex systems, war systems. We've come up with different social things. We've come up with democracy and capitalism and communism. We have all these things that we've come up from our minds, right? But we still do not know the limit. What is the limit of the human intelligence? We don't know that, right? So if we cannot know that as human beings, then we can't create a system that is even close to our human level of intelligence. And that's why general AI does not exist. A machine that thinks, acts, and applies knowledge at the same level as a human being does not exist. So the third one is the super or the strong AI, another dystopian view of the world where we think that AI is now more self-aware and it surpasses human intelligence. It's where we say the machine has grown a conscience the same way as a human being, right? That means a machine is able to emote, it's able to have emotions the same way as we have, right? And it's able to hold beliefs. And good luck or bad luck if they evoke emotions against human beings or have beliefs against human beings and say, you guys, you created us in the lab, you probably overwork us, but we're smarter than you, so why should you guys be doing this to us? We can flip the switch, right? So that is not possible yet because we haven't even passed the first route, which is getting a machine that is close to human level. So you might as well just breathe and know that these things don't exist. Strong and general AI do not exist, as much as you'll have a lot of pop and sherry in the media about all this. You will only see the Terminator in a movie. You won't walk down the street and hear of a Terminator in any way. So let us try as we go down artificial intelligence, we've already understood that AI in itself is a technology that is trying to mimic human intelligence, but under artificial intelligence with the types, which is narrow and general and super, and we've already ruled out general and super, right? So we're only remaining with one type of AI that exists, and that is narrow AI. But under narrow AI, let's try to understand now that we've already accepted in our minds that this is, stop all the media noises. This is exactly what it is, just an AI that is pretty good at one or two tasks. It is really good, but mostly just really good at one task. Then we move to the next level where we try to understand under artificial intelligence, this type of narrow AI that exists. What are the subsections of it? So the first and most significant subsection is called machine learning. So machine learning is the most popular AI that exists and probably the most useful, the probably the most useful to a majority of us. And even as we we have this entrepreneurship bootcamp. This is the only place you might perhaps just need to look at. And this is what we're going to focus on. We're going to focus on machine learning because it's something that is feasible. It's something that we can get to understand and we can get to actually implement and take time with it, right? So when it comes to machine learning, you might say, okay, what is machine learning? Machine learning is essentially a type of AI that learns from data so that it can interpret new information, right? So essentially machine learning is simply an AI that is able to learn from data and make predictions and recommendations uh, from data, right? So it is data heavy. It needs data. Without data, we don't have machine learning. We might as well just do something else, because if you don't have data, what's the point of intelligence if you don't know anything? I mean, even for us, the only way you get more intelligent is when you have the ability to interact with more knowledge and you're able to think through and learn techniques and apply them, and again improve from the same knowledge that you have gained, right? So if data is not existing, then what's the whole point? So what's the difference between our normal software, the apps that we have? What's the difference between WhatsApp and a bot and a Facebook bot, because that exists? So what's the difference? One is when someone made WhatsApp, they basically wrote software. They put a bunch of commands together and wrote everything that you interact with, from when you open that app, the first thing that you see, the charts, has been made as a command. The next thing, click on the three buttons, create a new group. All that has been programmed by someone, right? So I hope you'll appreciate computer programmers from here and software guys, because they make all these commands from scratch. They learn how to do it, and they do. They make these commands. They write these commands, right? So that is software, and it's pretty direct. But when it comes to machine learning, we take a different view. So the individuals here called data scientists and also machine learning engineers, who are able to just write a few codes, essentially just write a few codes that will tell the machine to learn from data. It's like, I cannot write 1,000 commands for you as a computer. Please, I'm going to just write this. I'm going to just write these few commands, and these commands will essentially tell you to learn from this data. Know the difference between an apple and a mango, and that's about it. And once you learn the difference between an apple and a mango, do that over and over again. Learn by yourself. Nobody is giving you commands anymore. Completely differentiate. If you're given a million images of a mango and an apple, please, by yourself, know the difference. And that's exactly what machine learning is. Ability for the AI to learn from data and make predictions and interpret and also give us insights and knowledge or intelligence out of it. So I think we've already covered that. Let us look at the types of under machine learning. We have to go down and understand, how does the computer do it? We've already understood that machine learning is just the ability for it's just an AI that essentially learns and interprets data, then makes predictions and recommendations. How is it able to do that? Well, it has different methods. Remember, with the same analogy that we are taking this AI to class, the same way we're taking our kids to class. Well, we're starting with one method called supervised learning, right? Supervised learning is now when we are the teachers. We are the teachers of this brilliant technology, and we want to train this um, computer to learn apples, to know apples, whatever apples will be presented to it, it will be able to know what apples is, right? But for us to get the computer to learn apples, the same way we get a kid to know apples, what do? We introduce images of apples, we introduce physical apples to the kid, and we tell them like, hey, Junior, this is an apple, right? I'm going to split it in half. Look at it. Always know that this one is an apple. So the next time, if I come bring apples again tomorrow and I show you, you should be able to know the apples, whether I put bananas on the table or not. So just the same way we do for computers, we essentially use a method of supervision. So where we introduce apples to a machine, and these apples, when we're training them, when we're training the computer, they're called labels. We just have a sticker of this fruit called an apple, and we train the machine to identify apples in different images that we present it. It will only have an eye for the apples, right? So what happens in this process is we show it multiple apples, right? So once it knows the apples, we test it by introducing images of apples, right? And it's able to, images of apples and other fruits. And it's able to only detect and pick apples only. So that is one method where we are actually supervising, we are hand holding the machine to learn apples. Now, let's take another analogy. If you have a child, or some of you have grown around siblings, everyone here is grown and might have shared a sister, a cousin, any kid you've ever interacted with, right? Let us have an analogy of a child and a gas stove, right? So if you light up a gas stove and you show it to the kid and you tell them, this is hot, this is fire, it will burn you if you put your hands there, right? So um, every time we want the kid to learn different fires, whether it's blue in color, orange in color, we take them to the kitchen, we show them, hey, this is gas, and this will actually burn you if you touch it, right? So after we do that, we show them when the gas is blue in color, the flame is blue in color, whether it's in orange, um, probably it's the end of the month and your gas is running out, and you cook every day and now the gas is out, so it starts to show this orange color, a signal that, hey, I'm about to go out, but it's still, it can still cook a meal, it can still make you breakfast anyway. So if you introduce the kid and show them, hey, the flame is orange, right? So they will know, again, that flame is orange, it can still burn me. So in the end, anytime the kid sees the flame, a blue flame from the stove, that's fire, I'm not supposed to go there. Whether it's an orange flame, they know they're not supposed to go there. So the child can recognize fire from the training that we gave them. Now, I'm going to go next to an example of this supervised learning. I'm not going to limit it to apples only. Yeah, I'm not going to limit to apples only, because this technology does not exist to recognize images only. I'm going to give an example that might be close to home. So Gmail, which is an email service from Google, essentially allows you to, it's probably one of the, free emails that you can have. Probably everyone here has it, right? But it has the ability to stop you from being, to being from interacting with, mails that are fraud, right? So most of us have probably gotten this, where you get this wonderful email from a West African prince, or for gents, it usually comes as, "Hi, I am a doctor in Mandera. I'm 24 and young. I'm looking for a husband in Kenya. I recently just moved around." Yeah, those kinds of texts and those kinds of emails that we get, or you find someone telling you, invest 10,000 and in 2 weeks will make you a million. Those types of emails. So what happens is, um, Google has over time learned that those are spam images. Those are images that are sent to you as a way to, they probably are not legit. It's just a fraud that is sent to you. And most people have already complained about it. So that means all complaints made by people using Gmail are data, right? All that are just data, right? And Google is able to take all that and train the machine. Every time you see this appearing in someone's inbox, put it as spam. Don't even let them read it. And the machine knows over time, every other time it picks anything close to that, hey, I am a prince from West Africa, it automatically to spam. You won't even see it. And in the spam folder, this sort of um, emails are probably gone after a month. It's completely wiped out. So you essentially are defended against all these types of crap. So the second one is when you use your voice recognition systems. If you've been in places or interacted with systems that need you to access them through your voice, so this is one way in which your voice the machine has been trained to listen to your voice over and over again to a point that is able to know if it's you or not. Another one is image recognition. If you have an Android phone and you have Google Photos, if you go to your Google Photos, you will always find that Google has had this ability to, split your images, differentiate you between this face and the other, your mother, your auntie, your cousin, even if you guys look alike. Even if you guys look alike, Google has found a way to make all of you, to differentiate between all of you, right? So how is it able to do that? Essentially is every time you take a photo, and Google Photos automatically saves it, right? Once it saves it, over time, you take another photo with your relative. Maybe it's in December, you've taken multiple photos of your mother and your siblings. All that is training to is supervised learning. Like the machine is just learning this face has occurred multiple times. Let me put it aside as an individual who should not be confused to the other one, even if you guys look alike. So that is an example of supervised learning. Uh, that is essentially just a machine that has been trained under supervision to recognize labels or features that represent something. Like if it's a fraud message, it will probably have this line, throw it aside, right? So another one would be another method that comes up is this unsupervised learning. Now, in unsupervised learning, this now is different. We are not telling the machine that these are apples, and we are also not telling the machine, we're not giving them any information. You're giving the machine any information. It's like you're on your own, right? We'll give you a bunch of fruits, and we want you to be able to know the difference between an apple and an orange and any other fruit that we have in place here, right? So let me just admit someone here. Good. So the machine has not been shown anything to identify. So the only thing the machine can do at this point is to group. It will try to look at, oh, apples are red, these are fruits in red, put them aside. These are fruits in orange color, let me put them aside. Well, these are probably purples, or these are probably, beetroots, let me put them aside. So in unsupervised learning, the machine is able to differentiate between different items on its own with no supervision. There's no supervisor. There's no one telling the machine these are apples, these are oranges. It has to do it on its own. So it can decide to group either.
Hivi umekula macho hapa?
Okay, let us mute her. Yep, fair enough. So in this case, as I was saying before that interruption, is at this point, we're not giving the machine any labels. We're not telling them there's apples. We just give it a bunch of fruits and letting it decide whether in color or whether in shape. So let's give an example here. Let's give an example here. And we have another example the same way as we got before, which is the child and gas. Good, fair enough. So we have an example of the child and gas again. So at this point, we have not told the child, if a stove is burning. The kid has to figure it out on their own. I don't recommend this to any parents in the house or any aspiring parents in the house, because this probably be futile to your child. But anyway, this is how we train machines. What do we have to lose anyway if it's machines, if it's computers? So in this instance, we let the machine decide. We let the child go touch the burning stove, which is blue, then gets burnt, right? The same way we let the machine decide if it's going to group these fruits as in color or in shape. It's on its own. So the second time, the kid gets burnt, they already know that stove when it's blue, I'm not going there. Now, the second time when your gas is over, it's probably end month again, and you go touch the gas and it's in orange, right? The kid goes ahead and touches the stove again. Then it gets burnt again, right? So once the kid has been burnt twice, the kid can now be able to know if it's blue light, you know, it's probably fire, it will burn me. If it's orange, it's going to burn me either way, right? But we did not supervise the child. We did not introduce them to know flames or not. The kid had to learn on their own. And that is exactly what we do with when it comes to unsupervised learning, when it comes to machine learning. A good example of this, for the most part, those who love to watch, I know it's been a holiday, so I know some of you are probably trying to entertain yourself with this. So a good example would be Netflix or Showmax. Remember how you open, first time watching Netflix and you start watching, you probably a certain show. Then the next time you come, to the homepage, voila, like you find similar movies are there for you, right? How did that happen? Well, what happened is the machine just looked at your activity or the type of movies that you watch and the type of content, who are the actors in the movie, what is the category of the movie, how long is the movie, what is in the movie. After doing all that analysis, the same way, we had to put oranges and mix fruits, and it had to figure out the interest, like which one will I group as oranges or as apples on its own. Same thing. Now the machine here looks at all the content you've watched and tries to group to what you might watch next, right? So that you keep on watching. You watch one and suddenly you find another interesting one, you watch again. And the guys at Netflix headquarters are clapping their hands and say, yes, it worked. We got him. We got him to, he wanted to do 1 hour and now he's doing 8 hours through. More money for us and more learning for our algorithm, for our machine learning, more learning to us, right? Another one which we probably, hopefully we get Viusasa there. Hopefully we get Viusasa to a level where it's able to learn our various content on its own in an unsupervised way. If you are working for Viusasa and you're here and you're an engineer there and you say, hey, I'm trying to do this, or we've already done this, come correct me. But otherwise, hoping we'll get to that level. So the second example is bank fraud. When a good example will be when you lose your card. Let's not even do the lose your card. Let us do a good example of, I'm here in Kenya. I swap my card here let's say I swap my card in Karen, right? Then all of a sudden, in less than 8 hours, I swap my card again in Kisumu, right? So then after that, I go ahead and swipe my card in Uganda. Well, whoa, guy, are you on a road trip? The bank has to call you and ask you, like, hey, you've been using your card. We've noticed some activity that is unusual of you. Is it really you who's making these transactions? Or maybe you've never used your card to buy anything online and suddenly you're doing it, right? How is that happening? Well, it's because there is an intelligence system behind trying to understand your behavior, how you how you make your transactions. You probably never travel as much. So how did you suddenly start traveling and using your card when you're out traveling? When you're out there. So it flashes that. So just to summarize that part is, when it comes to supervised learning, we give the machine labels, or we train it, or we show it before we test the machine. So it's able to accurately predict. But when it comes to unsupervised, no one is supervising the machine. It has to learn on its own by putting things of similar characteristics, classifying them. If it's in shape, put them aside. Red, if it's in yellow, put them aside. If it's long, if it's big, if it's small, it's able to do that on its own, right? So I want us to take a little bit of a breather and watch this together. I'm just going to again share my screen with you guys so that you guys can able to watch this. So let me just switch it up a bit. Then you guys will have to give me feedback if you, in any way, if I'm audible, if it's not audible to you, or if you have a good view or not. Ideally, I will still share the same on the chat so that you can pick it up and perhaps watch it at your own time. So let me just share on the chat for everyone. There we go. Perfect, right? Let me share that, but I will also open it up for those who can't do that right now.
Our ability to learn and get better at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves. But soon, we're learning and becoming more capable every day. But did you know that computers can do the same? Machine learning brings together statistics and computer science to enable computers to learn how to do a given task without being programmed to do so. Just as your brain uses experience to improve at a task, so can computers. Say you need a computer that can tell the difference between a picture of a dog and a picture of a cat. You could begin by feeding it images and telling it, this one's a dog, that one's a cat. A computer program to learn will seek patterns within the data that will enable it to recognise a cat or a dog in the future. It might figure out on its own that cats have shorter noses and that dogs come in a larger variety of sizes, and then represent that information numerically, organising it in space. But crucially, it's the computer, not the programmer, that identifies those patterns and establishes the algorithm by which future data will be sorted. One example of a simple yet highly effective algorithm is to find the optimal line separating cats from dogs. When the computer sees a new picture, it checks which side of the line it falls on and then says either cat or dog. Of course, there can be mistakes. The more data the computer receives, the more finely tuned its algorithm becomes, and the more accurate it can be in its predictions. Machine learning is already widely applied. It's the technology behind facial recognition, text and speech recognition, spam filters on your inbox, online shopping or viewing recommendations, credit card fraud detection, and so much more. At the University of Oxford, machine learning researchers are combining statistics and computer science to build algorithms that can solve more complex problems more efficiently, using less computing power. From medical diagnoses to social media, the potential of machine learning to transform our world is truly mind-blowing.
All right. I hope that was most of you could capture that. So, as a way to break off, I just want to have a couple of you unmute. You're going to do this in at least 5 to 10 minutes, where I allow you guys to speak to me as I have been speaking to you for an hour now, so that you can, if there's anyone we've left behind, I'd like you to speak up. If you can't unmute and speak to me, you might as well share something on the chat. Also, I'd also like to see, have any questions. If you have any questions so far to how far we've come, I'd like you to share right now with us in the chat. So I'm making the chats open for everyone to speak to me. So any one of you want to speak up, write something, share with me? Anyone we've left behind, you have at least between now to 5 to 10 minutes.
Hello.
Yes.
Quadrillion is how much to the power of 10?
Pardon?
1 trillion is how much to the power of 10?
I wish I was super, but I can't compute that right now because my focus is more on on getting this information to you, but I can't compute that off my head. If it takes us,
I know of a billion. I know of zettabytes, petabytes, but I can't really compute a quadrillion. Is it 10 to the power of 9, 12, 16?
is it you, Edith? Is you?
Yes.
I'm sorry, I can't compute that for you. Can we do that some other time? If you have any questions around what we have engaged so far, I'd take
No
that.
problem.
Yes.
Okay.
Hello.
Hello, Nduku. Yes.
Yes. I'm wondering.
Yes.
I'm wondering about you saying that when it comes to machine learning,
Yes,
a programmer writes a few lines of code
yes,
that trigger a machine,
yes,
you know, to learn and to keep on learning.
yes.
I'm curious. Of course, if you're not a programmer, of course, you won't be able to code. But is there a way for anybody, say like an entrepreneur,
Mm-hmm.
to tell a programmer exactly what it is they want a machine to do? What it is that they could what I mean I'm just trying to figure out
Mm.
if how do you handle this if you're a are you able to design anything if you're an entrepreneur and you're trying to figure out if you can create something that can help you with in your business?
Yeah, sure. That's a good question. Yes, you can. It's not, I know we have depicted this for the most part to be, sorry, I'll have to mute you a bit, but I just wanted to express that this is something that you can use. So it's not I know we've depicted it as a really technical conversation or a really technical um, technology, and it is. But for the use cases, you as an entrepreneur, you can sit in and use tools. That's the first thing that you can use, even before uh, programming or getting someone to do it for you. You can use tools that are existing for your business that have already had a whole team around it and lots of data around it. Do it for you, right? So that's the first thing that you can do. You can do tools, you can use tools to help you as an entrepreneur. The second thing is, yes, you can get a few people who can also help you implement this or get the right results that you want. So let's say you want to build um, you want to advertise your business on Facebook and you're trying to find the best way to even interact with your customers when they make orders, and you're thinking of, yeah, I think I'll build a Facebook bot that will interact with customers when I'm not around. And these are the kind of responses that I want. That's something that if you learn, you can do. It's not very technical. That's the first thing. But the machine is really good. It has been able to, at the back, at the background, it's able to know the type of audience that you're targeting and help you in that process of meeting them, of interacting with them. So that's the first part. The second part, if you want to build something that is unique, let's say you want something that does not have a ready-made tool existing and you want to build something new completely, then you can have a team of a few individuals who have the skill set, let's say a data scientist um, or a data engineer, and put them together and say, hey guys, I want to build uh, a machine learning model out of our customer data so we can offer better customer service, or I want to build something that is able to help us detect any sort of fraud in our process of hiring, you know, in our HR process, then you're able to implement that. So yes, it is possible on two fronts if you want something that is customized, or if you want something that you can quickly jump on a tool to do it. So there's that. Uh, how do you determine, a question from Gidinji Victor, how do you determine how much data is enough for the program to learn and not make a mistake? So I'll bust your bubble, Gidinji, by telling you you can't really say um, not make a mistake, because it's training, and that essentially means that the machine is going to constantly learn all throughout the process. So it's not something that you'll say and not make a mistake. A machine will make a mistake the same way a kid will make a mistake in their homework, right? So if we're speaking of how much data, I'd say start thinking from terabyte. For you to have a really robust system um, that you want to build, you have to have tons of data so that you can easily come up with something out of it, right? And that is mostly if you have a use case that you want to develop your own model. You'll need lots of data. If you just want to hop on a tool that you can quickly plug, plug and play the same way you say, hey, I want this to connect to my data and give me, insights on my customers or how my business is going to perform in the next 6 months, then that is different. That is a different use case. And if you're below 1 terabyte, I will be the one to recommend you to use that tool. But if you have a unique use case that you want to build your own, I'd advise you to get more data, terabyte and above. Go to petabyte. Just go for more data that you have. And I'll be happy to chat just how significant data is, especially between today and tomorrow, and why you guys, if you're in business or if you're an entrepreneur, you should be in a position to try as much as you can to gather data. Try to gather data as much as you can, because it's the best bet for you to use this technology, especially for a specific use case that you want to build on your own. Anyone else? Anyone else? Do you have any more questions? Anyone we've left behind somehow? Seems not. So I'm going to, okay.
It's 10 to power 18. I've got it.
Oh, you've got it? Okay. Edit?
Yeah, it's quite a lot.
It's quite a lot. Yeah, fair enough. That's why I took my plea and to let you know that that is not something I'd compute right now on my own. I'd rather share this knowledge with you, then we can go on about that later on. So glad you already have the solution.
Okay, thank you.
Anyone else with a question? We only have 2 minutes, then we continue. You can put it in the chat. Awesome. Good. Okay. Thank you for the comment, Gidinji. Yeah, I can't. Gidinji says he can't wait to learn how we can gather or collect such large amounts of data. Yeah, sure. We'll speak more on it, especially tomorrow, because I'd like us to, today is a form of introducing you to the technology so that the next time someone tells you uh, AI or machine learning, you know what you're speaking. If you go back to your business or you want to have a grasp of the implementation, you know what you're speaking and you fundamentally understand what the technology is all about. So no fluff, no, crazy terms, just the fundamental terms that you can know how this technology is and explain it to anyone else. So yeah, we'll dive more on how you can collect that data and use it. I think data is something we need to focus on more. So thank you for that feedback. Anyone else? 1 minute, then we come back. Then if that's not the case, then let's go back to our mute, but I think all majority of you have already decided to be on mute. So let's move past the engagement. I'd like us to talk about another type of AI. We've spoken about machine learning. Let us now speak of deep learning, right? So remember earlier on when I shared with you guys. Okay, good. Then let me just answer one more question, then we'll close up. Guys, if I close it up, I'll pick up the chat later on. But let me just take this for now. So Alfred Kitty is asking, when are we expecting full automation of systems in our country? I cannot speak for the leaders or all the scientists or all stakeholders in the country per se, but I can say um, try to be keen on startups. I've seen lots of startups, especially financial tech firms. They have ways in which they can, if you're trying to do a little bit of credit scoring, if you're trying to do something around that, they've been able to tap into some amount of data to automate systems of sorts. Um, there's still some startups in insurance trying to gather data and do that. So I cannot speak for full automation in the country. And I don't even think that automation will happen in full progress. As I said, the goal is not to get all systems automated and for humans not to do anything, but it's to get systems to be as automated as much as possible to complement us in our work and probably optimize us, or rather make us better in our work. So yes, so that's about it. I'm not going to take any more questions until we complete. I open up for another session. So right now, I'd like us to talk about deep learning. Remember when we spoke of Geoffrey Hinton, the scientist that was able to look at AI and say, how, if we're trying to mimic human intelligence, which part of human intelligence, which part do we, say represents human intelligence? And the organ that represents human intelligence is the brain. So his inspiration was drawn from how the human brain works, and that is something that he wanted to put in place. So what Geoffrey Hinton was able to do was he wanted to design AI the same way as the brain works, which is human brain has neurons, and uh, neurons are able to get human beings to reason and think, or and share information and process information in a much more detailed way. So it's not as similar as deep learning is not similar as machine learning, because essentially the reason why we put deep there is that we're getting more details. We have to think more of what you're saying. So remember when we said the child and gas, the child goes to the gas and touches it. Well, now, and we either show the kid an example of those flames so that they don't touch it, or we let them wander and discover. Well, now this one is a bit more complex. We make the child think about the decision of going to touch that stove or not, or even differentiate between, a flame that has just been drawn, it's not really burning, and a flame that actually burns, right? So it puts some thoughts and process to it. So as I said, it is drawn from an inspiration of how the brain structure is, the brain is structured and how it works. So the same way we have neural in our brains that helps us make the decision, it's the same way in this case, we're trying to get computers to think a bit deeper, right? So, and this requires lots of data, because if I tell you from far that that stove is burning, you are not too close to actually see and feel the flame. You are not very far to not think it's not a flame. So you have to think and understand, is that flame live or am I being just shown an image of it? Right? Now you have to think. Now you have to look at different things. You have to look at, um, are we indoors or outdoors? Is there a sufuria on top or not? If there's a sufuria on top or not, is it steaming? Can I see steam there, right? Is something boiling inside there? Can I tell from this distance that something is boiling and that gas is on, that gas stove is on? Now we have to think. That means we need more information. We cannot just look at the at the flame and say, okay, it's on, it's burning, it's a live stove. At this point, now we have to think of, we have to factor in all those different items in order for us to make a decision, right? So we are more detailed when it comes to deep learning, and we pick out multiple features. We pick out multiple things that are happening before we make a final decision. So this is how it works. We're going to use an example of a cat and dog. So if you if you're someone who loves animals, or maybe you don't love animals and you don't even care for them, but you clearly know a cat and dog, right? So in this instance, in this instance where we have a cat and dog, most cat and dogs might actually not might actually look alike. Some do not. Some look alike. So if you could see a cat and a dog, let's say let's put a scenario where it's a bit dark, right? And these two animals are not making any sound, no voices at all. Then they stand together. Then they stand together in one place. And they're not your usual domestic cat and dog, right? Are you able to pick the difference between the two if they are of the same size? If you see a cat and a dog that look alike, are you able to pick the difference, right? So you have to reason about how it works. So the same way we have to train a machine to know the difference between a cat and a dog, but from their features. So this is how your brain works in neurons. So different neurons pass different types of, there's lots of paths being taken in you making that decision. You start from the usual features that you know of. I'm just going to look at the sizes. If the sizes are similar, you're forced to think further. I'm going to look at the eyes, but they both have similar eyes, maybe orange or maybe orange eyes. And now you have to think again further. Um, I'm going to look at the wagging of the tail. Is it the same? I'm going to look at the ears. I'm going to look at uh, the cheeks. All that is factored in you making a decision, right? So after you think of all these features is when now you're able to make a decision between a cat and dog, right? So that means you need more data. You don't need the usual data of, cats look this way, dogs look this way. Now you have to think about it, and you need more evidence for you to make a decision. So how significant is this technology? I'm just again going to share a video with you guys so that this will be more fun. So through a video, so you can see how much or how far, deep learning has gone. Our ability to now get into more details. What are the benefits of us creating a technology that is more detailed, creating a machine that is more detailed and keen? Suddenly we can be able to come up with multiple of things. We can be able to solve lots of things. We can be able to diagnose cancer. We are able to diagnose pneumonia. And we are able to diagnose that at a very early stage, So before we get to the video, some of the uses of deep learning is when you go on your web and you search for, when you try to translate your language, let's say Zulu to Swahili or English to to Tswana or English to uh, French, any language that you might prefer, right? If you type in and if you type in anything in French, you type jamais and you translate it. What happens in the background to take that translation into into English takes a lot for the machine. That is deep learning in action, because what happens is that it will take that journey, the thing that you've typed in French, and be able to look through different records and even annotations, because French is written differently from Kiswahili or from English, right? So there's that annoying apostrophe there at the top, right? That you have to factor in. And now it has to run through a whole library of French language and how it's spoken and its annotations, all that. And after doing that, be able to give you a reply in English, right? Which is never. Jamais in French translates to never in English, right? So that is one example. Another example is in now to take it down further to some serious businesses, ability to know cancerous to know cancerous cells, if you have cancer at early stages or not. And that is something that is already being done, especially around lung cancer, where someone is, you go to the hospital, they scan you, and all those scans that are supposed to be looked at by a radiologist can now be passed through a deep learning machine and be able to give accurate predictions of your cancer. What stage are you in? Do you have any cancerous cells at any point in time? So let's look at this example. I'm going to open and share this video to you. I'm hoping you guys will be able to get it. I'm just going to go ahead and share my screen so that we can look at this. There's a new share. Let's get here and just share that with you guys and see.
This is how a radiologist diagnoses pneumonia.
84-year-old female, shortness of breath period, frontal and lateral views of the chest period.
This is an algorithm called
Pardon? Okay, good. I thought someone was speaking.
TechMindset that's trained to do the exact same task. And this is how it performed against 6 doctors analyzing 50 chest x-rays for pneumonia in a recent test at Stanford. TechMindset is one of many projects exploring how artificial intelligence can take over tasks normally done by doctors. And it has some radiologists worried that AI could one day replace them. That's because algorithms are getting really good at interpreting images and diagnosing disease, sometimes with greater accuracy than humans.
We'll take a picture of this X-ray. The model will then run, and within a few seconds output it all these diseases, and they're sorted by the order of most likely to least likely.
TechMindset was given tens of thousands of images and told which ones have pneumonia and which don't. Then it trained itself to recognize patterns and identify pneumonia in new X-rays. This process is called deep learning. In 2016, computer scientist Geoffrey Hinton, also known as the godfather of deep learning, put radiologists on notice.
People should stop training radiologists now. It's just completely obvious that within 5 years, deep learning is going to be better than radiology.
Part of the reason guys like Hinton say radiologists are replaceable is because they often work behind the scenes. Say you go to the emergency room with a really bad cough. The ER physician will order a chest x-ray, which is then read by a radiologist who gives a report back to the ER physician. Vice News spoke with Dr. Matt Lundgren, a radiologist at Stanford who's helping to develop new AI technologies.
As a patient, you're telling me that this process of reading my x-ray, which used to be done by a human, is now done by an algorithm. Why would I want this?
Well, so I don't even I don't feel comfortable with that, right? Would you fly a plane without a pilot? The situation that you just described is not one that has no physician in the loop. For narrow use cases, I think it would be a tremendous benefit as a patient to have, my doctor get information from some of these algorithms if they're shown to work.
What happens when the AI misses an important diagnosis?
It's something that comes up all the time. No matter what happens, if we are saying that we're going to use these algorithms clinically, there will ultimately be a time where an algorithm will make a mistake. The responsibility for the use of that algorithm will ultimately fall, I'm assuming, on a combination of the clinician and the healthcare system that's using this algorithm in that way.
All right, that's about it. I'm not going to stretch it out. So there we go. I'm not going to stretch it out. So the same way, deep learning is now more detailed than machine learning that we spoke about. It's more keen to the different details that come around when you're trying to make a decision, right? It's an important decision to decide if someone is well or not well, what's the level or what's the condition that they have. That comes or brings about a serious concern in your ability to be very detailed, as opposed to machine learning. Machine learning is still detailed enough for majority of tasks, but feels like medical need more keenness, right? Feels like medical need more keenness. Feels like finance also need more keenness in every way, right? So we've already walked through that. I'd like us to, again, go through two technologies, which are computer vision and natural language processing. The reason why we're looking at this is because it is close to, these are technologies that have existed without AI, but have grown so much out of the existence of artificial intelligence. So, good. So let's look at computer vision. And computer vision is essentially just a field that in computer science that is just focused on our ability to see. I think we already know of it, our ability to open our phones, our smartphones with our cameras. That is one example. Ability to show emotion, which a machine will now try to depict if you are sad or happy or angry in any other way, right? So what happens is that this machine is able to identify or pick up animals or projects or objects or people through a camera lens, like a live camera lens, or through an image. So it's able to identify you as a person, an animal, or an object simply by looking at your image or through a camera lens. Going to admit someone. Good. So essentially, how it works is a machine is trained, a computer is trained to identify. Let's give a very mild example, which is trained to identify your face and be able to know if you are the owner of this phone the first time you registered or not. There are some buildings that also require that. There are some banks that actually require that as KYC, which is know your customer as a service. That is essential. So it's essentially just a technology that gives the computers the ability to see, right? So what we do here and why we're even talking about it is because AI has dramatically, built this. It has dramatically improved the ability of computer vision. Now we have more purpose than to use our phones, to use this type of technology on our phones, as opposed to using it in a manufacturing place, right? So we can open our phones with it. We can identify or group different images with it. And this can go further to other business cases that we're going to look at tomorrow. So the second one is natural language processing, which is essentially just the ability of computers to understand language, whether it is written, whether it is spoken. And NLP uses artificial intelligence to take in, a human input. If you want to order for pizza, you want to order for something, let's say through a bot. Most of them, the most common one, and that why I keep referring to it, is the Facebook bot. If you haven't checked it out, you should just try and check it out and see what's happening, especially for businesses and how one can create. And there's more that you can even attach on different websites. I'm pretty sure if you go to some websites, you have a little pop-up there of an assistant that comes with that, right? So you can have, so essentially, let us look at an example that hits home, which is Zuri by Safaricom. Well, I'm not saying it is that smart yet. It can basically just buy you credit and do some very menial task that you can do instead of you dialing *544#. You can do that through your WhatsApp. But ideally, it hasn't gotten to that point where we can say it has a lot of intelligence. And the reason why this is one of the most silent use cases is because it is so hard to grasp language. I mean, if some of us still struggle with English and others still struggle with Swahili and all that, imagine learning at your age, trying to learn French or Germany, or let's say Russian or Mandarin. And let's hope we don't learn Mandarin by compulsory in the coming years. But if we're able to do that, it is difficult. If it is a challenge for us to do that, then it's way more difficult for a computer to do that, right? It is way more difficult. That's why, a company like Safaricom might not have implemented Zuri to an intelligent level as we might think a big organization like that with all that data can be able to do that. And they're still struggling because natural language processing takes a lot of research. There is so much nuance in how we communicate or speak. There is what we call context. When am I being sarcastic? When am I being genuine? And can a computer understand that, right? So that's why NLP has grown with artificial intelligence, ability for the machine to interact and process and make sense of language that we speak to it. And that's why there is other, voice recognition and voice speaking artificial intelligence bots like Alexa and Siri if you have an iPhone, and Google and Hey Google if you have an Android. They all piggy bank on natural language processing. So computer vision and natural language processing are these two technologies that were independent, but I know I would understand why probably some people who are experienced inside here would think it's a part of AI, but they just piggy banked on it. They essentially benefited from the existence of AI and how AI is grown because we are generating so much data, right? So I'm going to skip on this video. We'll wind up with it, but I want us to dive into this. Now that we've done all that, we've had all that conversation from us, AI to narrow AI to now machine learning, the most popular type of AI, and we've understood, how we train it in a supervised way when it's not supervised. And we've gone further to deep learning where we are now more detailed and we're using more data. So what makes the current AI happen, right? what do we need to get this in place and to actually implement this, right? There are three horsemen of AI, the most fundamental ones. One is processing power, because remember, as I said, we are using lots of data, and lots of data we're going to explore. Or I'm going to introduce a topic called big data. That essentially means lots of data, a terabyte to a petabyte and above, um, that we'll be using to train a model. Then the third one will be now the data models, which is now the ability to predict, learn, perceive and reason and solve problems, right? What have we trained the machine to learn? When we train a machine to learn, we place it as a model. We place it as a model. We call it a model. So when someone says a machine learning model, do not be spooked and wonder what he's talking about. No, it essentially means an AI that has been trained through data, a machine learning AI that has been trained through data, right? It's called a model, right? So there are three things that are essential: our ability to, the compute power. What computer can we put terabytes, tons of data in one place and go ahead and train a model out of it, right? Because if, just for example, if you use your laptop and you have a small RAM, you cannot use your computer really well. I mean, you'll open a few sites, then the computer hangs. Why is that so? Because you don't have the processing power. Um, you do not have a lot of space. You do not have a lot of processing power on your machine. Therefore, it just crashes, right? So these are the three essential things: ability of us to have data, lots of data, which we call big data; ability for us to that process that data; then now finally the data model that we create out of this process. So we've heard of a term I've just thrown inside there. Um, you're wondering now, what is big data? We only spoke of data only. What is big data? Well, let's dive into it. So big data is lots of data. Is just lots of data. And most of it's being generated in seconds. Remember, the world is doing 2.2 quintillion bytes every other day. So as a person, how much are you producing per day? As a business, how much are you producing? How much data are you producing at the office, right? So all that data sitting in someone's computer, aka the cloud, is so much data that we cannot just store it in our normal database. Your hard drive cannot handle 10 terabytes. It cannot. It simply cannot, right? And this data is gold, but this data is a lot. This data is essentially a lot. It is more than what we are used to, more than what we can hold on our hard drive and and mess around with it. This is way more. So the traditional methods of storing it is just not feasible, right? Because the data is just huge in volume and it's growing over time. So the more people are using their phones, connecting on Google Maps, is the more we are generating this data. The more we're generating this data, right? So big data is essentially just lots of data in volume, and still growing. Nothing else. Why is big data so essential to us? Well, because AI learns from data. If the only way it becomes intelligent is if it has access to data. So the more we interact to allow it to have access to data, the better the technology gets, the better the prediction becomes, the better the recommendation becomes. And that's why in that video, the more scans this machine takes, and it has already been trained on thousands of these images, the more it does it has interacted with those scans, the better it gets. But that data has to be a lot in order for us to generate intelligence, in order for us to have to say, this machine is quite intelligent. We can say imeenda darasa, imeenda shule. Hii machine imeenda shule. It's not my usual software. This one has gone to school, right? So that's how huge data is. It's quite a lot. It's quite a lot more than our phones can handle, more than our laptops can handle, perhaps someone's computer online, aka cloud. Now, how big is big data? We are used to kilobytes. I had someone try to shine on us on how much they know on these tons of data, but they got it right eventually. So there's kilobytes, there's megabytes. It keeps going. So I know most of you stop at gigabyte, Apple, GB, 16, 25. If you're a bit savvy, you go to terabyte there. But when you start speaking of petabyte, majority of us get lost. If we go down further, we get lost further to yottabyte. We get lost. There are companies that hold petabytes of data of us, like the Googles and the Facebook. They hold so much data. There's even local companies that hold so much of our data um, in place, especially these loan taking ones, these loan taking applications, the tellers and the insurers that have access to your M-Pesa statements, have access to your contact forms, and that is just you as one person. Now imagine how many people are borrowing in the launch of, in fact, in Kenya, the launch that we did of Fuliza, we were already hitting 1 million per day. Yeah, we're already doing that. So you can imagine how much data does that single person, user, if 1 million of you are taking Fuliza today, are doing an overdraft, how much data are you giving, right? If a million of you, let's say 500,000 of you are taking a loan from Tala or any other loan service, and it has access to so much of your data, just how much do they have of you as an individual and of all the others? Let's say you don't know how to play this game and you've taken a loan and you do not uninstall the application. That means it continuously still has access to your M-Pesa records and your contacts, right? Continuously. So your data on their cloud, on their systems is growing exponentially, right? And that's just you, one person. So how many more of you? That much of data is big data, right? So why is big data so important? Big data is important because AI needs lots of data. So, and how do we identify if something is big data or not? One, lots of volume. The volume is a lot. You're generating as an individual lots of data, generating as a business lots of data. So, volume is a lot. Second is velocity, right? Velocity essentially, which is just the speed in which you're generating that data by texting, video calling, making calls, checking things on your social media apps. You're generating fast. And variety is essentially you're not just texting, you are calling, you are Googling, you're interacting with 10 applications on your phone per day, all that, all that. And if you want to know how much data you're generating, honestly, just go to Google and just go to Google, the Google account itself, and try to see your search. You'll have so much. If you've never checked it out and you've been having your mail for 10 years, just try and go and see how much data have you generated in 10 years as an individual via your phone, and how profitable is it to a business? How profitable is it to an entity? And how much does it say or reveal about you? Like, can we predict your next action if you're going to move to a different city or make a purchase decision out of it? That's where we get to learn it from. So, having said that, I think we're going to sort of clear it from here. I'm going to share some videos as we engage halfway. So it's not going to be like it's the end of the session. I'd like us to have a conversation around different items. I'd like you to flood the chat with questions, or then you can let us have a discussion around it. Perhaps where you've been lost, you can share with us. So I also understand it has been quite technical. It might have not rubbed a majority of you the best way. If you are afraid of this kind of tech, I'm hoping you are not. I'm hoping you are encouraged to understand if this is how much this technology holds power to them. What, how is it, then how is it going to translate in how is it going to translate in the near future, right? How is it going to look like for you, or how can you tap into this type of intelligence and use it for your business, for your personal projects? Where can you start off with this, and some of the you know implementations locally and internationally of technology, as we've spoken of. So I'd like to allow you guys to unmute. If you have any questions, now is the perfect time for us to engage in them. So any questions? You are free to unmute and have a conversation with us. I'm here. I'll take all those questions. We can have a discussion around them. Feel free, if you're a bit shy, just write it in the chat. We can have a discussion. Any questions, thoughts, comments? I'd like you guys to engage. Yes, Faith, you can engage. I see your hand is up.
Hello.
Yes.
Mine is not really a question, it's more of a comment. And okay, I'm just like really grateful to have attended this class, because I feel like my knowledge prior to this was quite limited. All I knew about AI was majorly robots and movies like the Terminator. So I'm glad to know that there are like different categories of AI and all this information on data. And thank you very much, Coach, for taking us through it.
Okay, my pleasure. I think the field is quite vast. We underestimate just how much the field is vast, and how the applications of it, because we have painted this as something only big companies use, and a majority of us might not know existing tools that we might actually use for our own businesses to get this technology to be purposeful for us, or to help us achieve our objectives. So that's about it. So thank you. I'm glad you're able to learn something. Anyone else? Let me just see the chat. Guys are pretty okay. So Gidinji is okay. Let me just take it more. Okay, Martha Wambura is saying, personally, just digesting what I have been taught. Thank you. No problem. Just keep on digesting. It's okay. I know it might have been, we've summarized what people go to learn. You know, this probably takes, we do some cohorts around here at TechMindset, and this will take at least 1 to 2 months, just getting guys up on this. So we've been able to try and compress it in a way in which we can share with you. So I would understand if you're still digesting. So thank you. So I see someone here, Eric Mwangi, saying thanks for the very elaborate session. You're welcomed, Eric. You're welcome, Eric. It is basically just trying to numb it down so that today you can face your partner, face your kids, and share some information tomorrow, even as you go to your workplace, and share something. Talk about it uh, in a way that is very easy and fundamental. So Gibinji is telling network kicked me out on the big data part. Is it possible to collect and store big data? If yes, share a little bit about it. So yes, it is possible to collect and store big data, but I'd say it is expensive to store big data. I'd rather you put it in a service. I think services have gotten a bit more cheaper. So you have the ability to simply take whatever data you have and back it up. Choose a hosting service, a cloud hosting service that works for you. I would recommend like Google Cloud, because I think it's a bit relatively cheap. I'm sure there are others that are quite cheap, that you can take all that data and try to put them in the cloud, which is essentially just a service where you can store your data. So once you're able to do that, it gets easier for you to decide what you can do with it. So as a business, I'd advise you to collect as much data as you can. If you're keeping records in a book, now it's the time to try and take that data into a soft copy. Try to take all that data into tables and put it in a certain table and name it customers. Year 1, year 2, year 3, put that up. If you have customer feedback, try to digitize it. If you have records of your revenue, try to put it up there. Then the next part is, once you have this amount of data, now you can decide what you want to do with it. Do you want to get something out of it, or do you want to choose a tool that will help you, an existing AI tool? You don't want to build it by yourself or hire a team to do it. You just want a tool that will help you do something out of it, or bring some intelligence out of it, do some predictions out of it, do some recommendations out of it. So, and the existing tools like HubSpot, the existing tools, even Facebook is a good example. We're going to discuss how that can be done. But essentially, scrap all the data you can, man. That's all I can tell you, Gibinji Victor. So just store your data, store locally, then also back it up over time and arrange it. It will be beneficial to you. Any more questions? Any more questions, thoughts, comment? Any more questions? I see a new thing. Do you provide coding bootcamps, e.g. coaching on Python for machine learning, just to understand how to build data models by programming? So yes, we have an existing class that was taking people through the technical steps, but I'll have to talk to my colleague or on that existing cohort, see if it's still up or if it's a service that TechMindset still offers in place. But I'd say if you want to go the technical route, Python is good, for a start. I would, okay, Python is a good way to start. For those who are not getting what Python is simply a programming language that is preferred in building, a machine learning model. So Steve, allow me to note that down and ask for you. So join in tomorrow, might have feedback for you. We'll have feedback for you on that. So Eric Mwangi is, I was wondering, coach, is this thing AI this interesting? Because I already feel like I want to dig into it. So I'll follow up on that. How can we interact more with AI on a personal level? Is it at this point where someone will have to learn basics of analytics and AI and practice maybe basic coding for data stuff? So I'd say what type of person you are, it will solely depend on you. If you want to do this on a technical level, you can. If you want to just be knowledgeable enough to know how to use the technology, I'd say just try to understand the existing tools. So, not all of us are going to be data scientists or machine learning engineers, right? And I personally do not try to push everyone to be that, because I have a feel or taste of how difficult that can be, or how it will need you to have your interest. I'm not saying it's super difficult. I mean, if you're passionate enough for it and it's what you invest in time, I can tell you to do it. So you can start off on a personal note to do the programming part and try. I'm pretty sure there's so many online places in which you can learn that from. So if you want to personally interact with it, I'll give you a couple of examples in which you can just go check it out and see if it's something that you can play around with, or you can actually use it. Give me a minute to share it in the chat with you, as well as in the group, so that you guys can, as well as on the screen, so that you guys can see it out. Let me just pause. Go. Meanwhile, kindly keep the chat going up with questions. If you want to unmute and ask something, you can do that. So meanwhile, let me just share something interesting here with you guys. Okay, it's AI plus learning overview. So I'm just going to, let me share this in the chat for you, Eric Wangi. Just share with you. So this is a site called Teachable Machine Learning. Let me share the screen for that. Good, so everyone can see. So here we have what we call teachable machine learning. I'm just trying to share an example really fast, where Google was able to make this project open to everyone. Anyone can actually even get this plug and play. Essentially, if you want to have a system that can recognize different users, can recognize different poses, if you are in the medical field, or if you want to make something that is able to know the right posture or not. This will be the right or right thing you can play around with it. So let me just admit someone. Good, fair enough. Evelyn, thank you for joining us. So this the training has already been the model has already been trained for you. Now it's just for you to gather your data, train it, and export it. Once you do that, it's able to recognize images, it's able to recognize sounds and poses. And the best part out of it is you are able to take all that you've trained and actually use it for an image recognition project or a sound recognition project or a posture recognition project that you want to do, right? If you're trying to build something that people are coming in the events and you want to recognize the people who are supposed to be in the event and those that are not, well, guess what? They just have to come, camera scans them. No, you're not supposed to be here. Yes, you're supposed to be here. You're the right person to access this room or not, right? So the good thing with this is that once you train it, and you can train it on your laptop, you can actually train it on your laptop. Let me just show you as an example. I'm not going to do a live training with you guys, but essentially, you take an image, you upload. After you upload, it's able to come up with a way in which you can recognize that image if you share multiple images with it. Then after that, Google allows you to take all that and use for your project, for any other project that you want to be able to do that. Like you're able to export all that intelligence or way of doing it by yourself. So that's the beauty of it. Just going to stop the share now. So let me get another question. Will online learning programs, which online programs do you recommend for basic coding? There's multiple of them. I would recommend Code Academy is a good one. Code Bootcamp is also another good one. There's pretty enough free resources that you can play around with it. So, but I think now that programming has been made, available, it's not something people will wonder. Most online courses and in coding are not that bad, are actually not that bad. So you can pick whatever tickles your interest or according to how you learn, and you can take it up. I'll just advise you, programming is something that needs a lot of practice. So you might want to get a platform that challenges you to practice a lot, or if it doesn't, but you like the content, you can practice more often. It's the only way to get better at it. So yeah. Anything else? I want another question. Now that it seems like the chat is being filled by guys who are asking programming questions. I don't know where the business people are inside here. Come defend yourself before these guys were interested in technical part take over. Okay. Any other questions? Any other questions? Thoughts, comments? If you guys don't respond, then I'll have to come up with a question for myself and ask you guys so that you can speak to me. Would that be okay? Would that be safe? Would that be okay for you guys just to cheer you guys up? Okay, so Nduku is asking, could you speak more on data science, what it is, its application to AI? Good. So data science is essentially, it's multiple skill sets put together. It's programming skill set, it's a statistics skill set put together. Then what else is it? It's also a little bit of math. So most data scientists are actually, polymaths. They're guys who are able to have multiple skills and knowledge in one. They're able to program, they're able to understand statistics and a little bit of math and put it together, right? So if I was to speak on data science, the role of data science essentially is most is, I'd say, it varies. It varies according to different organizations. You'll find organizations where a data scientist is doing a lot of statistical work, where they're doing more statistical work. Another one, they're doing more programming work. But to numb it down, the fundamental role of a data scientist when it comes to an AI project um, is to essentially find use cases of data and train and come up with data models from them. So let's say we have customer data. What is the use case of customer data? The job of a data scientist is to have the first touch of that data, look at it, and try to understand, okay, we have customer data. What do we want to achieve as an organization? We want more customers coming back to us. We want customers to buy from us again, right? So the data scientist will now find a use case and say, if my goal is to get guys to buy more from us, increase the revenue, then I want to find or come up with a way in which, a model that will allow me to predict the next time a customer will buy from us, right? So what he will do is that he will take that data, try to put away the data that he doesn't need. So let's say I don't need, let's say, their ID numbers, or maybe I don't need their phone numbers because we're going to target them on email. So I don't need their phone numbers. This data is not necessary. There's some data that was not maybe saved well when your salespeople are doing, field work. So someone was supposed to write their name, then they wrote a number there. So you discard that data. It won't be useful when you make an AI model. So you push that aside. Then after pushing that aside, you now work on the data that is useful to predicting the next time you will, a customer will buy from you. So what happens on that time is the data scientist, after cleaning that data, that process is called cleaning. What happens after that is this data scientist will now come up or build a simple model that is able to predict. So now, once they build that model, through an algorithm, they look for a certain algorithm. I don't want to jump in and say all those linear regression and all that stuff. We're trying to make it simple. So anyway, they will create a model, a data model out of it. And once they've created it, they will take new data of customers. Let's say we picked data from customers of just yesterday, right? And we've analyzed and and cleaned it, and now we've made a data model out of it. The next thing we're going to do is we are going to share. Let's mute this person. The next thing we are going to do is we go ahead and introduce the model to the new data and see how it performs. So it will perform at an, it's a 80% accuracy, 70% accuracy, And now the person who is going to manage that after the data scientist has done his work is now a machine learning engineer. That guy will now take it, make sure it's in a place where data is constantly being there. He will watch its performance and if it's going on well or not. That is what he will do. So the role of a data scientist essentially is to actually come up with these machine learning models. And that's why they are a little bit of, tough people to find, especially the good ones, really tough people to find. But unless you want something that is highly specialized, you don't need to worry about them. But if you have an organization that has lots of data and wants to create something new, like a new machine learning model for something, you will need them. But for the most part, most of your work as a business will range, 2 terabytes. You'll get to a terabyte level, 2 terabytes level, 3 terabytes, and you might just need a simple prediction. You might not need a robust one. So you might use an existing AI tool. If not, if you feel you're confident, you want to build something new, or your use case is very different, then you hire a data scientist to come in, clean your data, and come up with a machine learning model that now you can use with the new data continuously. So that is the role of a data scientist. I'm sorry I had to go all the way, but the reason I had to go all the way is so that we can understand this role much better. It's very ambiguous, and most people might get lost in the details, but fundamentally that's just their job on a day-to-day basis, whether they're in Google or whether they're in a Kenyan startup. That is the job. So any other question you can shoot to me. Any other question? I am going to ask a question. How did you guys find the session? Was it difficult? Was it easy? Have you learned something today? So here, this one is an easier one. I'm not asking anything crazy. It's just an easier one. So I'd like to know that. Let me scroll. I'm going to admit purity. Yeah. Any thoughts on the session? What have you learned today? What is something new you can learn today? So Miriam Hari is asking, can we get the recordings? I'd like to watch it again. Yeah, sure. We do have the recordings. Joan will get in touch with Joan. This is recorded from the very start. So I see Martha Ombwets. It was very interesting, insightful as well. Learned a lot. Thank you for that. Thank you for that, Martha. That was the point for us to learn a bit more, and I'm glad we have. You have. Eric Mwangi learned a lot and was well presented. Thank you so much. Thank you so much. Try to dump it down so that all of us can get it and pick something from it. But at least I'm hoping, after this session, AI is not magic anymore. We've burst your bubble a bit, but now after bursting your bubble, today, tomorrow we show you the examples of local usage of this type of this technology, and in variety of fields, from agriculture to customer service to finance to international ones. Probably we will give you different a way in which you can start planning, like the strategy that you can have the type of team, if you want to have a specific use case, or if you want to go down to tools, how do we go about it? So Gidinji Victor is saying, you made AI look simple. Looks like a number of us are interested in the technical part too. So good. I made it simple. It takes a lot of interest to dive into that on a technical scope. I welcome you to the technical part of it. I'm on both fields of both the business and the technical, so I'll be happy to help you get on the technical part. So good. So Nduku learned a lot. Thank you. Glad you learned. Oh, so Steve is saying wild. It's a very wide field. Yes, it is a wild. It is a very wild and wide field. The reason why I preferred wild because you have so many varying opinions around it. So it's good to have the fundamentals and understand the technology at a fundamental level so that you can use it. So you can, the next time someone, your organization is trying to come up with something around it, you have a very fundamental understanding of it. It is wide because there is deep learning, there is, there's implementations around natural language processing where you can make bots. There is computer vision where you can make, KYC, know your customer systems that will identify banks. There there's other parts where you have machine learning, and there's in tools, there is in technical part. So it's a lot. It's a lot. Then there's also part of around ethics and how should we think about this technology moving on forward with what it has. So good. So here, so Gidinji also interested in technical part. Good. John will share with you guys on the technical aspect if you're interested in getting the technical knowledge moving forward. I think she will advise on that part. Okay, so Edith is asking, been recording my business prospects on Excel, like quotation, quoted amount, total blah blah blah, total supply, actual paid versus profit, actual closed goods, much less than actual quoted goods. Okay, how can AI help me close this gap, like enable me reduce cost in chasing customers versus actually realize sales? So good. Congratulations to you for being able to keep that in Excel. You are among the few people who are pushing digitization forward. So that's amazing. The second thing is, if you have that type of data and you're saying you want to reduce the effort of chasing customers versus actualized sales or realized sales, I will tell you, with the existing customers, try to come up with a customer profile, which glad you have Excel. We try, let me speak on the high value. Let's speak on how we can do it on a high level. So if I was in your position, if that was my business, what I will do is I will take the closed jobs. I'll know the closed jobs, the customers who have actually, materialized into realized sales, and look at that. So which are the ones I have closed in. The second one I would look at is I would look at the businesses that I look at the second part, which is the prospect ones, the ones whom we pitch to them, and you in business you'll always find those people who say, I'll buy from you. Yeah, we're definitely buying, but it's 8 months, but they've never bought. And you're always there at the office trying to see if they will buy, and they don't. So you spend more doing sales to them, and they're not going to buy, right? So there's prospects, then there's actual sales. So what I will do is I will try to come up with a customer profile of who buys, which cells have I actualized? So if I've actualized 7 cells this month, or let's say 1 year, I've stored this data for 1 year or two, and all this, I have this customer profiles of, I have actualized cells, 700 actualized cells for this year, and I want to have an understanding of who buys. So I make a customer profile of who buys, and I want to predict the person who likely fits this profile and will actually turn into an actualized sale. So I want to increase the number of people who are buying from me, and I want to decrease the effort taken in chasing people who will not buy from me. So make a customer profile of those people who have bought from you. Look at, you can look at the data will probably reveal things like demographics of like age, the location. That is very basic. Now, you go down further to items like, at what period did they convert? Did we close the sale in a month or 2 months? So closing period will probably be a factor. So we close this business or we close the sale in 2 months. So how many people among your 700, what is the average time did you close this? So you close it in 2 to 3 months. Good. So you've already noted that down. The algorithm has already gotten that. The model has already gotten that. Then we go further and look at the third thing, which is what other factors contributed to them closing a sale. So you'd find most of our customers only reached out to us. A majority of them, let's say, are in construction and they only bought items to us during this season, right? Maybe let's say end month when, at 30th, that's when they closed a sale with us. That's when they bought. So that's already an important factor that we have already picked up with our model. Then we look at the location, like is it in Kitengela where more construction is happening or not? Then you factor that in. So the profile that we can come up with is our customers, had this type of demographics data. Most of them were likely coming from construction field areas like Kitengela. We closed the sale in 2 to 3 months, and then time they came to us was end month, right? Then now, having gathered that type of intelligence, any new customer you are making a sale to, or any new prospect, or you want to advertise, you only target, when you go to Facebook and you want to advertise your service, you only target people or who fit that profile. And that is what you fill in on Facebook. Or if you want to come up with a unique model by yourself, now that we've trained it, it will only be looking for people who are likely to fit that customer profile. So in essence, we've already cut short the people will be looking for, who never convert into sales, and we've moved a step closer to the people who fit our customer profile to do it. This is coming from experience because we did something with a local airline where we are able to take their ticket sales and look at the customers, the profile of customers who are actually getting their business, who are bringing business to them, and who was, how many were they finding this airline via themselves, Googling and finding it and booking, or were they coming through agents? And we did the fast cleaning of data, and we found that majority of them were coming from agents, which was making this local airline pay agents more for bringing people. Now they wanted a way in which they themselves would attract or re-attract the existing customers directly. So we had to look at their ticket sales. We had to look at the places where the trips have, how many trips have been made in different regions and in what time of the period, and come up with a model that is able to come up with a model that is of a customer profile. So you have a machine learning model that only does customer profiling, right? And it's able to look at the current data and the bookings that are being made and notice this guy fits our profile. He travels 3 times in Mombasa per week. He probably has a business, an Airbnb or a rental business around the coast. So we are going to interest him with an offer. So it makes a list of all the people whom in the next morning their sales guys are going to make offers to. And the conversation will be like, hey, Mr. Nzioka, we we noticed you've been we noticed you've been doing trips in Mombasa. We'd like to make you an offer. So this Thursday, when you go for your usual trip, you're going to reduce that by 10% or 20%. So if you book directly with us. So essentially, people start booking directly to the airline as opposed to the agents. Why? Because the airline has discovered the type of customer profiles that they have existing on them. And that is how your business or your business is able to grow, or you're able to achieve your things if you have that kind of intelligence with you in place. And the more data it has, the more it learns to be better by itself. So that's the beauty of technology like machine learning. So you're able to learn, it's able to learn by itself. Nobody is touching it anymore. So I hope, Edith, I have completely bet the horse to death with that one. If you want a more uh, deeper or other views around the same, tomorrow we still have a session, so we'll be happy to have that chat too. So any other question, thoughts? So customer profile, demographics, yeah. What other factors of season time, closure targeting? Steering through, narrowing down, repeat customers, new engagement. Thank you so much. Good. I think you have, or what other factors in terms of seasonal time? I'm just trying to read through what she's sharing. So customer profile, demographics, location, items, closing period, average closing data. What other factors? Season or time of closure, targeting specific profiles, sieving through, narrowing down. Okay. Okay. Okay, good. I thought it was a question coming through. That's clear. If I've helped you edit, I'm glad I could. Yeah, so just look at your data, try to understand um, who's buying from you, make a profile out of it, and target that profile only. You probably see some changes coming your way. Yeah. Oh my God. 15, I'm sorry. Okay, any more? Any more questions? If there isn't any more questions, I'd like to probably call on John. Or if there isn't, we still have at least 15 minutes. So if there isn't, then perhaps John will tell you what we can do tomorrow with you guys. I'm hoping you guys will come join in again now when we can speak more of business and what type of data you hold as a business. We'll be probably be looking at now what are some of the implementations in AI. I'm hoping you'll be excited about the local ones. People trying to do a few things around that space. I'm hoping you'll have perspective with the international ones. Then we'll see what can we do? What strategy can we lay down as a business to try and do that? How are we able to store our data? How are we able to make our data valuable to us in order to do that? And what tools will we be looking at to do that? So Gidinji, Victor, so great insights, also learning the language of business. So thank you.
All right, Coach, thank you. Thank you for an amazing presentation and breaking it down so well. And I'm glad also to see that the students are appreciating the same. And the fact that people want to delve deeper into the technical aspect of it, please stay tuned. There's that option coming up. So this announcement will be made tomorrow. So that now that you understand the basics, what's next? Okay, so we're excited you're driving towards that agenda. And yes, we look forward to going through another part now that the coach is going to brief you on. And after that, I think you're good to go and do whatever that you're doing. It's interesting that for some technical people are their hearts and minds are open towards what businesses can be done with AI, but at the same time, the business people are also mesmerized by what AI tools can be done. I love the cross mix, which is, I think it's an amazing insight to look into. So let's proceed for tomorrow's lessons. From my end, I think, Coach, you've covered most of what we wanted to cover today. And I've seen all the questions have been covered. I don't think there will be any further than this. Would you want to brief us on what's happening tomorrow?
Yes, I would. I think tomorrow will be much about diving into data and trying to see how this technology relates to businesses, small businesses. I understand small businesses is not equivalent to the Googles who have tons of data. So we're going to explore how, what strategies or what aspects of us will we be able to take in data or use data that we have for this. The second, we will explore some of the industries that AI is making an impact. So tomorrow will be more about the examples and how the magic behind the examples that we see every day. We'll even go further and explore the local, what other local startups are trying, or local SMEs and companies are trying to do this, and also mix up with the internationals. So tomorrow will be a place where we now dive into the examples. Today we've shared with you what the technology fundamentally is. Then now tomorrow we dive into the examples and now the strategies in which you can put in place to collect data. And hopefully on the third phase, if you join us further, we'll be able to now go through the tools that you can use as a business to it. So that's about it. I'm hoping you'll be excited to join us tomorrow.
I'm excited myself. So I think we can end the session here. This was good timing. Excellent. I hope we'll keep the same tomorrow, but tomorrow might go further as we delve into now what the next phase would be. So Coach, I'm leaving this up to you to plan on the time, possibly 2.5 hours, and then we use half an hour to get to understand the next steps, right?
Yes, sure. I think we can still do the same time. We had a good turn up. You guys showed up. Some of you were already here by 5:40, 5:45. So really nice. So I think we'll do the same time, 6 to 9 tomorrow. Yeah, we'll do the same time, 6 to 9 tomorrow.
Okay. It's also not too late to bring in your friends, your colleagues to listen to the second part, though possibly, I don't know, maybe the coach would start again with like 5 minutes to recap on today's lesson. But if you still have the opportunity and chance to bring through your friends and your colleagues for tomorrow's session, that would be great. We'll be happy to have more of you tomorrow. All right. So thank you. I will share recording to your emails, and I'll also share recordings to the group so that we have some valuable information as we move forward. So thank you, everyone. Have yourselves a blessed evening. Please go and take a rest. Bye-bye.